Okay, we're going to talk about the Polygon angle sum theorem. Now, where we started with this lesson was actually back here. There are two links in the geometry classroom, the Polygon interior angles, and this is where we started. So this site just lets us play with the angle measures. So if we go and change this to 3 sides, you can see the triangle adds up to be 180 degrees. Okay, if we change this, so it's not regular. Regular means angles are congruent and sides are congruent. So if we take that off, then when I move these angles, you can see up at the top, and you add them up, you can see all these angles are changing, but it still stays 180 degrees. And that's something that we already knew. Triangles, some of their angles, 180 degrees. So then I can do 4 angles, and again, I can change. And then what you'll notice up at the top, no matter where I put my angles, then it changes. Okay, now that you do not want a concave, it does not, I don't think, well, maybe it does. It does add up correctly to 360. Usually we think of convex polygons, but concave polygons work too. Okay, so then we can do more sides. Pentagon, 5 sides, you can move the angles around, and you can see that no matter what, these angles, the sum of the angles are going to stay at 540. And so then the same thing, hexagon, and then you can keep playing with that. So that's where we started. We moved some of the angles around and saw what we could find and what the pattern was. So that's what we were looking for, is what is the pattern. Well, and then here, you know that triangle has 3 angles. The sum of those angles are going to be 180 degrees. So number of sides, 3. And the number of triangles is 1. Total angle measure 180 degrees. Okay, for 4 sides, this is a quadrilateral. 4 sides, and you saw that that was 360 degrees. We'll talk about number of triangles in just a minute. Okay, 5 sides is a pentagon. So 5 sides, and that was 540 degrees total. 6 sides is called a hexagon. So 6 sides, and that is 720 degrees. 7 sides is a heptagon, and that will be 900 degrees. 8 sides, octagon, and 1080 degrees. Okay, so then back here for number of triangles. Well, if you look at this quadrilateral and I go from one vertex and I go across, it splits this quadrilateral into 2 triangles. So the number of triangles I can have is 2. And if you'll notice, 2 triangles times 180 degrees equals 360 degrees. I can do the same thing with a pentagon. So here to there, I've got 1, 2, 3 triangles. So each triangle 180 degrees. 3 triangles times 180, 540. Same thing with a hexagon. So I have 1, 2, 3, and then that lines, and that's going to make 4 triangles. So 4 triangles, 4 times 180 is 270. So you can see the pattern. So 5 triangles will be a heptagon. 5 times 180 is 900. 6 triangles times 180, 1080. Okay, so What we're looking for again is the pattern. So we can see that each one of these increases by one triangle each time. So we're adding 180 degrees each time. Okay, there's another pattern though. If you look at the number of sides and then the number of triangles, it's always 2 less. So a pentagon, 5 sides, but take away 2, 3 triangles. Octagon, 8 sides, take away 2, 6 triangles. Okay, so that's the pattern that we're looking for, and that makes up this polygon angle sum theorem. So n is the number of sides. So the number of triangles, okay, 180 degrees, is going to be the sides minus 2. So for example, number 1, what is the sum of the angle measures of a 10-gon? So that just means a polygon with 10 sides. Not all of them have special names. 10 sides, I think you sometimes hear it called a decagon, but much more than 10, you're just going to see like the number of sides. All right, so 10 sides. Well, if it's got 10 sides, that means I'm going to subtract 2. It's going to have 8 triangles times 180 degrees. So 180 times 8 is 1440, 1,440 degrees. Okay, number 2, what is the sum of the measures of an 18-gon? So again, okay, 18 sides, but the number of triangles that it will have will be 2 less than that, and then times 180. So 16 times 180 is 2880. So 2,880 degrees. Then equilateral polygon, equiangular polygon. Okay, well, we've talked about equilateral triangle before. That's all 3 sides are congruent. Equiangular triangle, all 3 angles are congruent. Okay, well, the same concepts will apply to polygons. So equilateral polygon is a polygon with all of the sides are congruent. Equiangular polygon, polygon with all angles congruent. Okay, so if you put those 2 concepts together, you get a regular polygon. So it's a polygon that is both equilateral and equiangular. So meaning it's a polygon that has congruent sides and congruent angles. Okay, so sides and angles are congruent. So give an example of a roadway sign that is a regular polygon. All right, we came up with a couple of them. The yield sign is a equilateral triangle. Okay, so all 3 sides are the same, all 3 angles are the same. The other one was our stop sign. Okay, you probably know that one. That's an octagon. But again, all 8 sides and 8 angles are congruent. Okay, now this is kind of this corollary. It's just kind of like an offshoot of our theorem, our formula that we were using. So you'll notice the n minus 2 times 180. So that is the measure, how we find the measure of all the angles, the sum of all the angles in a polygon. Okay, but if you only want one angle, okay, you don't want to know all of the angles, you want just one angle, it would be the n minus 2 times 180 and then divided by n. Okay, so divided by 6 if it's a hexagon, divided by 12 if it's a dodecagon. Okay, if I only want one angle, I'm going to take the sum of all the angles and then divide it by the number of sides, and then I just have the measure of one angle. Okay, so example 4, what is the measure of one angle of an octagon? Okay, so 8 sides. Well, I could, oh my goodness.
Sorry.
It's okay. Hold on a second. I'm going to pause. I'm back. Sorry, I had a student come in and they scared me because I did not see them coming and I didn't hear them walk in either. Okay, so we want to know what the measure is of one angle of a regular octagon. So if we want to find all the angles, it would be 8 minus 2 is 6, and then 6 times 180. So all of the angles, hold on, 6 times 180 is 1080, 1080. Nope, I did that wrong, I think. 6 times 180. Nope, 1080. Okay, but we only want one angle. We don't want all the angles. So that's why I'm going to divide by n. And in this case, our n is 8 because we've got 8 sides. So if I divide that by 8, you get 135 degrees. Okay, so 135 degrees for each of those angles. So when you look at a stop sign, all those angles, 135 degrees. Okay, example 5. I have a floor tile pattern using squares, regular hexagons, and regular dodecagons. A dodecagon is a 12-sided polygon. So my question is, what's the measure of each angle in just one of those dodecagons? All right, so I'm looking at 12 sides, but I'm going to subtract 2 because it has 10 triangles in it. So that's going to be 10 times 180, but I just want one angle, so I'm going to divide that by 12. So this is going to be 1800 divided by 12, and each one of those angles is going to be 150 degrees. Okay, so that wraps it up for today. So 2 concepts here. The sum of all the angles in a polygon, you can find that by doing n minus 2 times 180. And then if I just want one of those angles, I find the sum of all the angles, and then I can just divide by the number of sides, and then that will give me the angle measure for just one angle. All right, so